Okay, a memorable story is about the time when I almost got arrested in Hawaii. I always had a lot of collaborations with Japanese colleagues, and once they asked me to transport some bacteria to Hawaii, where we met for a conference. So I was flying from through Honolulu to a big island, and when I am changing planes in Honolulu, there is a loudspeaker calling my name and saying, "Well, you have to surrender your bacteria." And they look through the big book of dangerous bacteria and they don't find my bacteria, and they say, "No, you have to surrender them." I say, "No, you would have to stop the plane, they're in my suitcase." They say, "Fine." Then at the Kona airport they will confiscate your bacteria. Then we land in Kona and there is a very nice guy coming out and taking my bacteria and said, "You can get them back when you fly back." Okay, and I said, "It will be my Japanese collaborator who will pick up those bacteria." But it's Sunday and their office is closed when my Japanese colleague flies back. But these people were so nice that somebody drove from home on Sunday morning, unlocked the office and gave him the bacteria. Since then I have the deepest respect for Hawaiian people, and in particular customs officers. My name is Leonid Brown. I'm a professor at the Department of Physics, University of Guelph. I got all my undergraduate and graduate degrees at the Moscow State University back in USSR, and then I moved to California and I worked at the University of California, Irvine for almost 10 years before moving to Canada, to Guelph, and I've been here since 2002. The main topic of my research is interaction of light with proteins. So I work on microbial proteins similar to our visual proteins from algae and bacteria, and we try to understand how they work and what they do, because they do all kinds of things, not just sensing light but also using light to produce energy or to produce chemicals which are needed by these organisms. That's one topic, and the other topic is looking at our membrane proteins in more general sense. Again, using these light-sensitive proteins in membranes, in cellular membranes, and also using other class of proteins, aquaporins, which has water channels, so they're responsible for water transport in and out of the cells. Normally it's 5 to 6 students. Some of them are shared with Vlad Ladejansky because we are collaborating on common projects. And interesting feature of our team is that it's very interdisciplinary, because we are doing a whole spectrum of things from biology through chemistry to pretty complicated spectroscopy. So we have students of all backgrounds. We have people with biology background, with biochemistry background, with physics background, and biophysics. It's also usually very international. We have international students and Canadian students. We also usually have undergrads. Every summer we take some, and some of them stay to work during the semester. Again, it depends on their educational background. I always try to match their skills with the projects, and because there is a huge variety. And so some undergrads, when they come to the lab, they learn microbiology and biochemistry, and some learn spectroscopy. Some students just do bioinformatics. They just use computers, they never enter the lab and do theoretical projects or computational projects. That's a very interesting question, and it will be a very strange answer. I actually was always interested in biology as an elementary school and in high school, but I also very much attracted to math. So I went to a magnet school with enhanced math, and then I started studying in a school of biology, but I wanted to use my math skills, and they said, "Oh, biophysics is the best mix of the two." And so this is how I started biophysics. I didn't know much about Guelph or about Canada, actually. I just knew a few people who worked in my area who were Canadians, and they recommended Guelph. And then I came for an interview, and I found the department very welcoming, and people very accepting of any scientific background, and yeah, and it's been great ever since. So it's a very collegial department. I learned over the years that we had an amazing staff. So I got along very well with everybody, and I got so much help and support from our admins and machine shop and IT people and electronics people, lab supervisors, you name it. So it's been really easy to work with a very good, relaxing setting.